Just one
Yeah,
thing. I have a small issue here.
sure.
I'm not at home today, and I don't have the charger, so I'm like running on 50% battery. And
Okay.
at some point, my computer will die, and I have an alternative computer here. Is it
So shut down
possible?
shut down the video, and mute your mic. That will save some battery.
No, no, but I have an alternative computer. If it's
Oh,
possible to send the invitation with the Zoom to another computer, to my private email or something, so
absolutely,
yeah,
absolutely.
okay.
What? Absolutely. Let me show you how I do this, and you can do it yourself. Okay.
No, I know how to do it. I think I just need to add the Zoom to send it
Shahar,
to.
where are you now? Maybe I can send you a charger.
No, no, no. I'm in Langwitz. I'm on the other side of town.
So what I do is simply click here, copy the link,
Yeah, yeah, yeah. I know how to do
and
it.
then I share it with you on WhatsApp.
Okay, just don't want to do it without your permission.
Oh yeah, that's fine. That's really fine.
Okay.
All right. Let me find our group. Da, 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 da. Here we are. That's the link for today. All right. So you all have it. Um, and Shahla, that's fine if you cannot um, if you cannot have your video, and that's really fine. That's really okay. Alan, I'm looking at what you sent, the question that you sent, and I'm trying to understand the problem, the issue that you had here. Um, primary. Oh, okay. I see that. That's a typo in the
Yeah.
question. All right. Thank you. Thank you.
It's not a
That's
problem with the
great.
question, the problem is the typo, just spare A.
Yeah. 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 No. No. You're right.
I
Uh,
have another
I noticed it
question.
in 250 in that night, so credits for that.
yeah. Yeah.
Um,
That's great. That's great that you guys give me feedback on the questions and typos here and there. That's great. That helps us, make the database even better and more approachable for others. So thank you
We are
for this.
contributing.
I saw a question, and I'm not sure if it's right or wrong. There is a question which says, which of the following offers confidentiality to an email message?
Uh-huh.
The correct answer that you said that is written is the sender encrypting it with the receiver private key.
I sent this
Yeah,
this
this is
question to Han from the beginning. I didn't get an answer. I'm also confused because I think that the test is
I think I replied to you and I said that was a mistake in the system.
that's a mistaken
It
encryption
that
in general. So
no, you're right, you're right. Send it to me again because I thought that I fixed it. Because Carlo, I got it from you, but I think I also got it from Ran. So send
okay.
it back to me. I'll fix it on the database. That should have been the public key. Okay.
Okay.
Uh,
of course.
thank you. No, that's great. That's great that you guys are helping me. Make it better for others and for us as well. All right. Um, so, how are you this morning? You guys okay?
Very bad after domain 3. It's
Yeah.
always giving hard times. 55%, 60. This is the maximum there.
But
Always you are getting questions always like, what is the case size of that? What is the block size of this? What is that? So this is memorial questions. You just have to remember them. Give us a
Told
table. Give us a hint. How?
Right.
Add
Let me
more RAM, add more RAM.
let me ask you this, Carlo. I agree. I agree. There are questions, memory questions. But let me ask you this: before yesterday, when you were asked about the key size or the block size, would you be able to differentiate between them, to understand the differences between them before yesterday?
Let me say that it's a fact that before yesterday, I had 50, 60% average. After yesterday, it's still the same. So nothing has improved, at least from the results in the. So I think maybe we need a different system here. You know what I mean?
Okay, man. I get what you're saying. Wow, this is awesome. Okay, the more you practice, the more you know. I'm sure of that. Alan, did you have a question?
No, I clicked it by mistake. Sorry.
All right, I do have a question for you. Yeah, Valentino?
I think I've never had to Google an English word as much as I've done now. But thing is, so English is not my main language. Like Afrikaans is my main language, but English is pretty sufficient, right? Like my English is not bad.
Yeah.
Like there are some words that I had to like actually Google to find out the definition, and I was like, okay.
Can I help your ease your pain and tell you that even the American audience that I teach Google part of the exams. They also Google part of the words that they encounter there. So don't worry about this. You're not alone.
Okay, great.
English is not my mother tongue as well. So as good as it sounds, your English, you have an excellent English. But sometimes looking at the CISSP, you don't really think it's English there. Out there, it's not really English, right? Doesn't make sense. But yeah, that's a problem for everyone around the world, including the US.
Okay.
So I do have a question for you guys, and I would like to challenge you a little bit. Um, let's say the Pentagon, we're talking access control modules, right? Let's say the Pentagon is now running vendor assessment on an organization that develops, I don't know, electric circuits for them. Okay, the DoD is running an audit on their vendors. What can they expect the vendor to have as an access module implemented for that vendor that is solely work with the DoD? The only client they have is the DoD. What should be the access module for that vendor?
That would be that EAL levels, right?
Yeah.
No, the access module.
Ah,
The access module, Bella Padula, Biba,
Work
and so on. So what will be the ideal access module, or what can the Pentagon or the DoD expect that vendor to implement as an access module? Bear in mind that they only work for the DoD. The only client they have is the DoD, the US military, the US Defense Forces.
Then it should be Bella Padula.
Bella Padula?
Hmm?
Okay. Why is that? Why do you think Bella Padula should be the access module?
I don't know. I have a feeling for that.
Oh, you have a feeling for that. Oh, that's awesome. Your feeling just cost you $700. What do you think, guys? No, Carlo, if Bella Padula is your bet, then let's try to protect that answer. Let's try to explain the answer. I'm not saying no. I'm just saying, what's your explanation behind this? Just to brainstorm, and that's really how we learn. We brainstorm, we understand. If there's a mistake, we understand the mistake, we benefit from the mistake. If it's right, then we all know how to line up with this. So what led you to say Bella Padula as an access module?
If actually the client is the Pentagon, and means that actually they're the only client over there, and knowing that they're dealing with very confidential information, even secret and top secret, makes sense if they have to construct something very specific for them. Let's say to not let everybody on the pipeline to have access to this, let's say, information, and just break the information in their structure, like so everybody who has to, let's say, to deal with a specific part to have access only to this thing.
Right. Got you. Okay, makes sense, right? Makes perfect sense. However, I would like you to go back to that slide.
But it's a fact that it's not a government institution. So we said yesterday that actually these two models, Biba and Bella Padua, are actually governmental models, but
Right.
This is fact.
That's,
I
that's
agree.
exactly why I wanted you to go back to that slide now. Just have that slide in front of you and look at it. Just have it in front of you. Take a look at it. And if you remember, we drew a line after. So what we said is the first part, the first two are for government and military, and exactly what you just said, Carlo. So in my state of mind, as I approach the CISSP exam, and I get this type of question, it's not just memory question. What is the block size or the key size? The maximum key size, Carlo, this is a question for you. The maximum key size for blowfish, what will be that one?
1048 or 248?
No, look at my hand.
4096.
448, man.
448.
But that's just a memory question, right? I don't want to take you that route of memory questions. This is more of an understanding question. And the understanding question are the level 4 and 5, and you want to have more of these questions. So let's look at the slide that we have with all the modules, okay? The access modules. Thinking CISSP. They try to lure me into that military government world when they say the only client is the DoD, right? Perfect. However, for government and military, if I choose Bella Padula, I cover only part of the access control. I cover only confidentiality. So if I'm to choose Bella Padula, who's to say that I'm not to choose Biba? And if I choose Biba, who's to say that I'm not to choose Bella Padula? You see where I'm going with this? Okay. There you are, Shachar. Perfect.
Sorry,
You're
guys.
logging in from Eva Schuster's computer?
Yeah, this is my girlfriend.
Oh, okay. So I see you twice on my screen now.
Yeah,
I
let
like
me
that.
just
This is the profile and this is the front. So
exit 1 second.
okay, cool. Anyway, going back to that question. So, Carlo, are we in understanding of the confusion that is
Absolutely.
embedded in that question?
Absolutely. You ask a very tricky question.
You might be right. If the word confidentiality would be there, then I understand why choose Bella Padula. But since no confidentiality or integrity is in the question, then I'm saying I'm ruling out both options because I cannot choose just one of them. If I'm choosing one of the military and government access modules, I have to choose the other one as well. And since I need only one answer, then both of these two answers are now dropped. So for the CISSP, I started with 4. Bella Padula and Biba were one of them. Both of them just dropped. And now I'm left with, let's say, Clark Wilson and Brunash. Okay? I need to choose one of the two. So which one of the two, Clark Wilson and Brunash, makes more sense to me? Let's think about it. The fact that this is an organization, a vendor, means that they are commercial business, right? They're a business, and their goal is to make money, right? To grow. Today, they have one client. Its name is the DoD, Department of Defense. But who's to say that tomorrow they will then have another client? They can have the what do we have in Germany? Department of Defense. Well, what do we have in Germany? Ministry of Defense. What is it called? You guys don't know.
We don't know.
No one knows.
I think it's called Bürgeramt, but never mind.
No. It's not that, but we don't have a German here to enlighten us.
Oh.
Germans don't have army. You don't know that it's not allowed.
Oh, come on.
They do. Actually, they do.
It's called Bundeswehr.
Where do you think Israel buys all the military equipment from?
From
Germany. They're the best of the best. No, what are you talking about? Ask our prime minister. He can tell you about this. But no politics. Forget about it. Okay. Anyway. Let's call it Ministry of Defense of Germany, okay? And let's say Germany enters in contract with that vendor, and it's an agreement with the DoD. What will be your access module now of the Clark Wilson and Brunash?
Jonas,
There you go. Why is that?
because of the Chinese wall model over there. If they have a second customer tomorrow,
Exactly.
so we want to prevent a conflict of interests here.
Right. Exactly. So if you have two clients, Chinese wall would be great. If you have one client, the right answer is Clark Wilson. This one will handle authorization and auditing. Since it deals with auditing, it will provide the DoD the right evidence for the audit they want to run, right? Because I mentioned that the DoD is coming to audit that organization. Do you see where I'm going with this?
Mm.
So the audit, DoD, and organization with clients. They want to make money, so Biba and Bella Padula are out. They have one client, so we don't need the Chinese wall, and they're running an audit. So auditing for Cloud Wilson is great. This is how you tie that answer together, okay? And I wish for you that this will be the questions that you will get, okay? If you'll get the size of the key of the blowfish, I would be a bit worried about your exam because you're going further away from passing it. These are questions level 2 and level 1. You just need to remember the number, 448, okay? All right, then. So yesterday we started talking about, we're still in domain 3, and we started talking about this topic called trusted computers, or TCSCC. The trusted computer has one goal behind it. Trusted computer area or environment or requirements. It has one requirement, one main goal behind it. The main goal is to produce machines, computers, okay? The objective is to produce computers with the level of trust in security that to the industry. So if the industry is the highly classified DoD offices, then that level of manufacturer needs to be the highest one, EAL 7.
By the way, Chen, you kind of lied to me yesterday.
Did I lie to you? Really?
Yeah, you lied to me במצח נחושה.
Really? Wow.
Guys, no, because I asked you like how deep they go with the EA level, and you said yeah, maybe they will ask you how many levels they have you have, and then I get a question yesterday. Which level of EAL you need in order to
Let me ask the jury here. Okay.
yeah.
You your accusations. Dear members of the jury, what do you think? Did I lie to Shachar about his exam?
Well, I got a question that asked what does EAL level 5 stand for? Like
Exactly.
what?
Exactly.
Perfect.
I got the
Perfect.
same question.
The accusation is horrible. You're saying I lied to you. I lied to your face. Have you taken
In the eyes, Chen, in the eyes.
a second? I'm trying to work with you. I'm trying to bring you down as a witness. Did you take the exam?
No,
Did you take your CISSP exam yesterday?
no.
There you go. See? I didn't lie about practice. In practice, you're gonna get hit hard because out there in your CISSP exam, you have 100 questions.
Yes.
And this is something you need to remember. No, I'm being serious now. As you register for the exam, as you pay the $700 and you register and you book a date, in the database of ISC, what happens now is that an exam is built for you. All right? We have 8 domains. All of them are level 3, 4, and 5. All right? That's how the exam is built. You now have your name, Shachar Gober, and an exam of 100 questions. When I talk about your exam, and you can expect one question from here, 2 questions from there. 5 questions from here. What I talk about is that initial questionnaire, initial 100 questions exam that is built for you. So from all the topics, ISC will probably, if they have the room for a question on the TCSC, the criteria of VAL, it will be probably for 1 question, not more than that. But for the Biba and Bella Padula, it can be up to 5 questions. You know, encryption, symmetric and asymmetric, can get even to up to 8 questions. That's a lot. So what we're trying to do here in the bootcamp, you know, regardless of going through all the materials and understanding everything and remembering everything, what you're trying to do is to cover, you know, do a work by the Pareto. Cover 80% of the exam, or even more, 95% of the exam in 20% of your time. So make your time very efficient. Does that make sense, Shaham?
Yeah.
I'm sorry, I didn't mean to lie to you, but I
No,
meant for you to work hard.
I was joking, just that
I know you were joking, but I'm not gonna.
I saw this question, and after you told us that, yeah, you maybe need to know that there are 4 criteria, but not to know exactly what each level means. And then I see a question,
A question, another question, and another one, and yes.
and a question that
That's
says
the
exactly
genius.
what is EAL5, and you know, and I said like this bastard, he lied to me, you know.
All right, I take this, okay?
I
As
know.
long as you pass the exam, I don't care. Accuse me all you want, as long as you pass the exam.
No, but it's good an example of the depth that you need to go in order to pass the CSS.
Yeah. So think about it this way. Every domain, because since they want us to get 70% of each domain, for every domain, they have the average of 12.5 questions, right?
Mhm.
8 domains, 12.5 questions. You don't have half a question. So for one domain, you will get 12, and for another, you will get 13 questions. So if you are the one, for example, to write your own exam, and you look at the book, 1,600 pages, right? 1,600 pages. Or let's look at forget about the book. The book includes a lot of other areas, glossary and practice questions and all that. Let's look at the presentation. So we have 670 slides of material. Let's say 650 without the header and footer and all that. 650 slides, you need to take them and put them inside 100 questions. How do you choose? And that's the beauty of it. I myself write exams. I write exams for the university. I wrote questions for ISC. I wrote exams, full exams for ISACA. And that's the beauty of it. When I write the exam, at the end of the tunnel, there's a person. Okay? And the way we write your exams is that we look at the full material, 670 questions, 650 slides. And now I need to choose the most important one to understand, but also the most confusing one. Okay? So I wouldn't say EAL is the one that comes to light when I look at domain 3. Okay? There are a lot of other areas that I can either attest that you're a professional, but also confuse you enough. And I give you the Biba and Bella Padula, you know, easy as that. 3-4 questions there, boom, that's it. You know, I got you confused. And if I got you confused on one of them that is level 3, what happens next? You get the level 2. You get the level 1. And that's where I can put in the AAL. Okay? What is level 5 EAL? You know what? I don't give a damn. Because when I'm a CISSP and I'm a CISO of Lockheed Martin, I will simply open the book to know the level of EAL manufacturing requirements. You know this? So to grant you CISSP, the exam that I will write for you will include a lot of other areas before the other 20% that we're not really touching during this bootcamp. That's what I think, you know, all of us need to understand, that there's a person behind this exam. There's a person that will actually attest on us. And by the way, you know, you're more than welcome to do it with me or Ran. Ran is a CISSP certified. we can both endorse you as you pass your exam. There are people behind this processes, and that's exactly what we're dealing with at the end of the day. All right. All right. I like these accusations. I like it. You lie to my face. I like that. I like that because it takes me to court. LA law and all that. I like that. All right. So as we started
If
speaking
you
about,
ask me, just one small thing. If you ask me, is what my takeaway from it is always trust your knowledge and be prepared as much as you can, and don't trust anyone else who tells you, yeah, you need to know this, you don't need to know this. Just learn as
yes,
much as you can and know as much as you can.
true, very true, very, very true.
Bottom line,
Trust your
Chen,
guts.
you lost Shahar's trust.
I don't think so, man. I don't think so. I think I gained a lot. Okay, so we talk about trusted computers. In the name of trusted computer, we have the base, we have the goal, the objective here, which is trust. Trust between a customer and a vendor. Okay? The customer tells the story. The customer in this case is the DoD, Department of Defense of the US federal government. They want to buy hardware. So for them to buy the right hardware for them, that will not include anything that is rogged, anything that is tampered with, any hardware that is spying on them, for them to be able to trust the hardware. Let's say it this way. If the DoD really wanted to trust 100% of the hardware they use, they would probably need to manufacture it themselves, right? Right? Is that true? Right? So manufacturing the laptops, the cell phones, the computers, the screens, the smart cards, the proximity cards and proximity card readers, and electric doors and electric mechanisms and AC, right? Air conditioners, and every computerized machine they use. If they wanted to have 100% trust, they would have to manufacture it themselves. And even when they would do that to get the 100%, there are still people at the end of the chain, right? And people can bribe, can double cross you, can spy for the enemy, right? We've already had that cases before. So the DoD understands the risk, and now they manage the risk. They say, okay, I have a certain risk appetite, very, very low, okay? So for level 7, okay, which is the highest requirement for security, I have the lowest risk, but still I need to trust someone. I need to trust my vendor, all right? So in order for me to trust the vendor, these are the requirements. I need you to go through this, all these checks. And even when the vendor, EAL0 and EAL7, no matter who, provides me with the hardware, what do you think? The DoD doesn't check them? They sample the hardware, they tear it apart, they open it, they look for the raw components on the electric circuit, the chipset that shouldn't be including this and that nanotechnology. They still do that. They still every, but they do sampling as much as we do in a SIM system. We sample logs, and we will talk about that later on. So the DoD needs to trust their vendors. Trust is in the base of risk management. That takes me back to domain 1. The risk appetite, the threats, the vulnerability, the probability, and the impact. Okay? So in order for the DoD and any customer to trust the hardware that they buy, we, as CISSPs in the side of the vendor, This is our position now for TCSE, right? We're at the side of the vendor. We need to understand what can be the requirements for manufacturing this hardware for the DoD. Does that make sense? This is where we stand. We are the CISO of Intel. We are the CISO of Dell. This is your start point when you look at TCSE. Okay? Well, maybe you should write it down. Let's go back a couple of slides. Yeah. Here, I want you to look at this slide. I am the CISO of Intel. Okay? Seriously, write it down. I am the CISO of Intel. Now, all questions that you will get on this topic from here onward, the view, the point of view, the angle that you take on this question is I am the CISO of Intel. Okay? This will help you and direct you to your right answer. It's not the DoD. You're not the CISO of the DoD. You're not the buyer. You're the supplier. And as the supplier, you need to be able to work in the acceptable level of risk of your client. It's not for you. You're not asking, why do I need it? You're asking, how do I create trust, high level of trust with my buyer? All right? How do I strengthen the level of trust, or how do I make it higher, the level of trust I have with my client? That's TCSE. All right, make sense, guys? All right, perfect. So we talked about the different requirements of the DoD, and we mentioned the different categories, and also mentioned the rainbow series of the books. You know, we have a book for network security, operating systems, risk management, and database security. That's the four you need to remember. There are more books out there, right? But that's the main four you need to remember. So now, as we look at the hardware that our factory or our company manufactures for the DoD, there is, for example, a requirement for confinement in hardware, for bounds in hardware and isolation. There is a requirement for isolation of something, isolation of process. Okay, how do we do that? So in the process of manufacturing this hardware and programming the software, we want to make sure that there are two processes that takes place before we can actually achieve isolation of a process. The first one is confinement or quarantine. So basically, the definition of the boundaries of the process itself, right? So what is the perimeter of the process within my machine? And then I want to say, in your memory, this process uses part of the memory. I also want to see the bounds, okay, the bounds of the memory for that process. Hi, Jaga, good morning. Okay, so I want to see the bounds, the boundaries of the memory. So now I have the definition of perimeter for the process, okay? And I do have the definition of the perimeter of the memory it uses. Together, now that I understand both maps, I can define the isolation or the isolated area for that process, okay? So the two of these together will create the isolation of the process. So let me ask you a question. Why would the DoD ask for isolation of a process? What will be the case study behind this? What is the goal behind isolation of a process?
Prevent memory dump.
Coming in?
Prevent memory dump. Prevent.
No confidentiality.
What was that, Cal?
Confidentiality.
I'm sorry, I don't understand what you're saying again.
So with confidence.
Oh, confidentiality. Yes. Confidentiality of what?
Of the data? Of the
of
process?
processing the data. Yes, processing the data. Let's say we have a server, let's call it a mainframe, okay, that the DoD uses. Now the DoD needs hardware for that mainframe. Okay, they buy hardware that can actually do isolation of the process. And why is that? Because some of the processes that they use on the mainframe to, I don't know, plan a military operation somewhere or design the next jet fighter, all right? They want to isolate that area because of confidentiality needs, okay? The whole process needs to be isolated within that machine. It's just like having a segment inside your network. You have an external firewall, but you also have an internal firewall to protect that area, okay? This is where we want isolation, to protect, to keep confidentiality, to keep high availability maybe on that process, but we want this process is more sensitive processes. That's why we want it isolated, okay?
But you're touching your point of how do you design systems. I mean, you
That,
have to you have to design the whole system in. I mean, this is the holy grail of application security to
exactly,
process
exactly.
run in a confined environment. Yeah.
Right, exactly. And as a CISSP, as a security professional, you can be asked, this is a requirement of the DoD. What do you say? Shachar, you're the CISO. What do we need to do? Direct us. We know how to develop the system, but what is isolation of a process? Okay, so in order to get the isolation of the process, we need a definition of the limitations, or the perimeter of the process, and then the boundaries of the memory it uses, and now we can do isolation. This is how we do isolation. The development team needs your direction as a CISSP to understand the requirement and how to achieve it. Okay. Yes, this is part of application development programming in general, but also manufacturing. You know, I assume that the CISO role of Intel has a mandatory requirement for CISSP. So you will not be able to be the CISO of Intel unless you have a CISSP. Okay. All right. So next one. Next part is another definition. Some more definitions of the way trusted computers work. We have some definitions for multitasking, multi-threading, multiprocessing, and multiprogramming. Multitasking, I assume you know what a multitasking is, and the logo, the icon that you have there says it all. We all like to think that we are all multitaskers, but guess what? The wife is always better multitasker. No matter what you choose, I personally, as a man, cannot really be a multitasker. So basically what we say is that we have more than one application running on the same computer in parallel to others. Multi-threading is saying that we have multiple concurrent tasks for a single process. Okay, that's the multi-thread. Multiprocessing means that we have few processors working together, okay, in parallel to each other. And multi-programming is for mainframe, mainly mainframe and legacy technology. Now, this part is the part that I don't know how to explain better than what I have here in the presentation, because, for this part, when I read through the book time and time again, this part, I got hit by a wall. I don't know what example to give you other than the DoD and Intel and the vendor that we already talked about. There are few requirements that are put out there for clearance of people, right, users, and the system they work on, the project that they actually work on. So when you look at this slide here, this is a less important slide because it includes a lot of information. What I want you to look at, right, so I want you to tag this slide as the less important one. Okay, all right. Valentino, you with me?
Yeah.
All right. This is a less important one because the next one gives you the better explanation of what it is that you can expect. So up here we have the people, okay, and the clearance that they have. And down here we have projects that they work on. So if the users are working on a dedicated system, this is a quotation, dedicated system, system high mode, compartmented system, or multi-level, they have different requirements for access to classified information. Okay, they for dedicated system, which are considered the highest level of security, they need clearance, they need access permission, and they need to use need to know. All right, and as we go down from dedicated system through system high mode, through compartmented, and at the end of the game, multi-level system, you know, their set of requirements that we have for security is going down. Okay, so all of them require clearance, multi-level requires nothing. System high mode will add, and dedicated systems will require access permissions, right? So someone to really give the permissions for all users. And for dedicated systems, this is the only system, this is the only project and only system that we work on that we get, that we have to implement the need to know principle when we give permission for all users. All right?
What is
Make
system
sense?
high mode?
That's different definitions of levels of projects or manufacturers that we work on. Just like the EAL, but there are different levels, right? So you will get the definition of your level. Your level now is compartmented, okay? This is a definition that you get from your client. And as we said, I am the CISO of Intel now, okay? So if this is considered a compartmented system or a system high mode, let's say system high mode, then now I need to make sure that all users have clearance, right? And all users are managed one by one the access permissions that they have, okay? If this would be a lower level, we're talking about compartmented, then all I need to make sure is that all users have clearance level. I can also do access permission and need to know. That's a good one, but I don't have to. It's not a mandatory requirement, right? We all good?
Mhm.
All right. Let's look at the way the hardware itself works. So we talked about the different, talked about asset management too. Here we talk about the way the hardware itself works. So we have user mode and we have privilege mode. The user mode, we have the different rings, and I'm sure you're all familiar with that. You're all familiar with that. You've all heard about this, and we will talk about the ring layers after this again. But just to understand, the first one talks about the way the user acts. The user actually uses the application, uses the hardware from hardware to application. The minute we switch on the computer, we go from ring 0 all the way up to ring 3. Okay, and it reminds the layers, the different layers that we have in the OC model in domain 4 in network that we will get to later on today. So the user mode speaks about the way the users uses the computer. Privilege mode is the way the system uses itself. So different processes and different areas of the system act as subjects on part of the system that is now an object. And for that one, we have system mode, kernel mode, and supervisory mode, okay? Different modes of a system, okay? It's called privileged mode. And as we look at the layers of the user, again, from ring 0, which is the hardware itself, okay, the way we switch on the computer, it starts all components, all chipsets on the board, on the motherboard, and then moves up to the first level of software, which is calling the operating system, okay, and then brings up all the drivers as my Windows goes up, right? All the drivers and utilities and everything that is behind it. And as I log into Windows, now I can access applications and programs. So this is the different areas. And for every ring, we can get different requirements for security from our customer. Okay, the DoD can come in and say, okay, for drivers, you're only to use Intel and HP drivers. I don't want you using any Lenovo drivers or any driver that is not signed by the manufacturer itself, okay? So this can be our requirement. So the requirement for this one will be on ring number 2, okay? You see that? Ring number 2 speaks about drivers, right? Ring number 0 are the requirements for the hardware itself, the motherboard itself, right? As we look at the way the hardware works, and time again, we look at the different areas of the chips and so on. Now we look at the memory. Okay, and the memory management the way the memory is programmed to be managed by an application, a certain application, is key to the security, because a lot of times the computer, what it does, it operates on the hardware. But we require from the computer, we require from the machine a lot more than it can do immediately for us, okay? We ask the machine to save a certain file, 2 gig file, okay? The process of storing this file, even if we have super fiber optic, quickest infrastructure you can think of, that some memory. The memory, the machine act as if it's doing multitasking, right? But not necessarily all the time. It can do the actual multitasking. So it needs to use memory, whether it's a quick, RAM memory or warm memory. Okay, and we talked about the volatile and non-volatile. So part of using the memory is, the way it's programmed, and we will see that a lot today. Programmers and software engineers, developers, they know how to address the hardware and to call certain areas of the memory for use of the application. If they don't do that, then the memory stays as a hardware alone, doesn't have a use. So for the application to work properly, they need to call some areas of the memory and use them, and have them dedicated for their application. So they kind of color them and say, for this one, for the Microsoft Word, this is the area of the memory that I'm going to use, and this is where I'm keeping part of my actions, okay? So as they do that, there is a vulnerability called tuk-tuk, okay? Tuk-tuk, so you can remember that I was doing like the tuk-tuk, okay? Tuk-tuk on the door. So tuk-tuk is really an acronym, stands for time of check and time of use. Okay, tuk-tuk means that from the moment that the application stored information, sensitive information on the memory, okay, it just processed the information and stored it on the memory. Now it takes a couple more seconds for the application to say, oh, I know I stored it somewhere, and now I'm going to take it to access the memory. There is this period of time of 2 seconds, right? During this time, maybe someone can access the memory if it's plain text, if it's written, as everything else, plain text in that memory, someone can potentially penetrate the system, find that piece of information, super sensitive piece of information, order of attack somewhere in Afghanistan. They can find it on that piece of memory and pull it out. So the tuk-tuk really helps us understand the concept of memory isolation. If you want to do memory isolation, consider encryption. That one is more tricky than any other encryption because it encrypts and uses encryption on hardware. Okay, so encryption means that I need to store the keys somewhere, probably in a hardware next to it, or a different hardware that is plugged in to the computer as I access this part of information. Okay, so tuk-tuk is a reminder for us that even a split of a second that sensitive information is stored aside. I will get you in a second. I just need to put that piece of paper here for a split of a second, and I'm turning my back on it. Someone can access it and use that information against me. So for us, security professionals, when we work with developers, we need to consider that as well. Okay, so the memory management of a system. And again, talking about the memory, different types of memories, and we saw that yesterday. We talked about the ROM, EEPROM, and EEPROM, and flash drives and RAM as volatile memory, and all that. We covered this yesterday, but you see, different angle for the same concept, okay? So memory, as you use flash drives, when you work with the Department of Defense, they will probably not allow you to use flash drives, but if you will use flash drives, those flash drives will either be DoD issued, so it's theirs flash drives, they give you those flash drives, or at least they will ask for an encrypted flash drive of a certain level of encryption, not the DES encryption, but something harder than that. Okay, RSA can be a good one, and others that are also. So let's capture everything that we just talked about. We talked about isolation. Okay, we talked about the isolation of a process on a hardware. We talked about layering. Okay, one control cannot provide all security. We need different controls. Abstraction is really when you put the controls in groups. And here we talk about processes and the way an application works actually in abstraction. Data hiding is encryption, and we talked about a lot about the data hiding and data hiding on the system level as well. Okay, and hardware segmentation helps us go back to that isolation process, and hardware segmentation inside a system might be a requirement to use not only certain type of hardware and certain vendor of hardware, but also different areas of hardware. So inside that hardware, you also need to have the ability to kind of slice it into those areas that you want to use and you're able to protect. Does that all make sense, guys?
Can you repeat that, please?
Repeat what? Everything. Let's start from the main one.
Yeah. So isolation is running two different processes.
Right. Yes, isolation. Isolation is the isolation that we saw previously when we talked about achieving the isolation. We need to first understand the process and the boundaries, the perimeter of the process, and then we need to understand the memory area that process actually uses. Only then we can get isolation. Right? Layering is again different layers of security within the application, within the hardware itself. Abstraction is groups. We want to treat the controls as groups. So black box interfaces for programmers. Okay, another part of the grouping. Data hiding, all about encryption and levels of permissions that we grant processes and certain applications to work on that data. And hardware segmentation is, again, different manufacturers, different hardwares, slices within the hardware that we want to be able to work on and isolate, going back to isolation, okay, in those different areas of the hardware. Now, bear in mind that we might be talking about not the laptop or cell phone or a PC. We might be talking about F-35, which is a huge computer, okay, that includes pieces of other computers and subsystems, and it's all one giant, hardware that operates together and is isolated here and isolated there, and memory usage here and took to there. This we're talking about. So when you consider this type of system, it's not the mainframe of a bank. It's a warship. It's an aircraft carrier. This is what we're talking about, okay? And as you think about this, also consider SCADA systems and ICS, industrial control systems for power grid, for nuclear power, okay? For an aircraft. Commercial aircraft. That's what we talk about. These are the systems. It's not our PC at home, okay? Because for that PC, yeah, all this is relevant, but you know what? I'm not sure that PC can be a target of that type of threats, okay? China will not infiltrate my PC just to get to my PC. They will probably use that to hop to something bigger than me, Okay, and vice versa. The U.S. will not target anyone's PC. They target the big systems. And
So-
for us, the CISSPs, to be able to protect those systems, we need to understand that there are a lot of processes inside. Hardware, software, the way they connect, okay, and the basic terminology of the protection levels that we can actually provide those systems.
So each one of these terms is a consideration we need to take when designing or testing a system, right?
Exactly, exactly. And as you do security by design with your developer team, okay, in Intel, these are the terms that you need to consider.
Okay.
All right? Cool. All right, guys. Let's take a 15-minute break, all right? Because the next one is another chapter. So this will be our next one. So 10, 6, 10, 17, we'll reconvene here, all right?
Okay.
All right, guys. Drink a lot of coffee.